Okay, I want to talk about 4 basic subspaces. So, one of the basic subspaces is the range of A. So if A is matrix, let's just say this matrix. Note that this matrix has rank 2, nullity 1. And it's easy to see the nullity is 1 because the third row is just the sum of the first two. Of course, we could do any similarity transformation and that wouldn't change anything. Transpose, incidentally, is this, and that's going to be important. So, the matrix T is a mapping from R3 to R3, where T of x is defined by A times x. We're going to call T prime the transformation, where T prime of y equals A transpose y. So T maps R3 to R3 in this direction, and T prime maps R3 back to R3 in the opposite direction. And we might say that this is our space V, and this is our space W. So T is a transformation from V to W, where V is one R3, W is another R3. Okay, so again, if T maps from V to W, T prime maps from W to V. So here's V, and here's W. Okay, well, the null space of this transformation has dimension 1 because the rank is 2 and the nullity is therefore 1. So there's some subspace of dimension 1, and we can easily find that subspace that maps to the 0 vector. So that's indicated by this blue blob here that maps onto the 0 vector over here. Then we have the range of this transformation, and that's going to be a 2-dimensional range. Its basis would be the rows of A. And we see that simply because if you multiply A by the vector 1, 0, 0, we're going to get the first row. Multiply by 0, 1, 0, you get the second row. Multiply by 0, 0, 1, you get the third row, and those 3 rows then have to appear in the range. Now those 3 rows don't constitute a basis for the range because these rows are not linearly independent. The 3 rows span a 2-dimensional subspace of R3, and that's our range space. So there's range space. Okay, now the transformation defined by, it's not an inverse, transformation defined by the transpose has similar characteristics. You have the range of the transpose here, and you have the null space of the transpose. It maps again to the 0 vector. Now these, now we talked about your 4 basic subspaces, and that's plural, might as well. Subspaces. R of A is spanned by the rows of A, as I just indicated. Rows of A are not linearly dependent, the rank is 2, but they span this subspace. Null space of A is the dimension 1 subspace, and its set of solutions of the matrix equation AX equals 0. So just set A times vector x1, x2, x3 equal to 0. Row reduce it, find your solutions, you'll find that there is 1 free variable, and you get a corresponding subspace of solutions, and that's been done quite a while ago. Then you have the range of A transpose, which is spanned by the columns of A. Okay, it has dimension 2 because the rank of A is 2. So the columns or the rows span a two-dimensional subspace. So we have that here. That's the range of A transpose. And we have the null space of A transpose, set of vectors over here that map to the zero vector. Okay, I'm going to do this in another video, shorter video.